Hello everyone. We will start our presentation today. So our presentation's topic today is about dynamic analysis with Greatech Advanced Design software. So my name is Farshad Purchar. I am the local product manager for Greatech products for Canada and US. My responsibilities in this position. So first of all, I'm taking care of all of the technical support and the training. We are doing the specification and localization of the graphic software for Canada and US. As well, I am also doing sometimes development, and I'm helping our development team to make our software better and more user-friendly. So let's go on to the next slide. So first of all, I really hope you are healthy and safe, all of you, and family and your loved ones. So I hope you stay safe in this like difficult situation and difficult times. And I hope everything will be okay soon. So for the agenda of our presentation today, so first of all, I will talk about a bit like general dynamic behavior of structures. Then we will go through like types of dynamic analysis. Then we will mostly focus on advanced design, what's new on this subject in Advanced Design 2020. After that, I will have the presentation directly inside AD, and I will show you how to use these new tools on dynamic analysis. Then we will see some slides in case you are interested in Greatech software, where or how you can contact us. We will talk about Greatech Team-Up Digital Conference, which is coming soon. And finally, we have questions and answer session. Just to let you know, in GoToWebinar, all of you are in mute mode, but you can always ask your questions or type your questions using the question tool in GoToWebinar toolbox. Or as well, I'm going to show you my email and the last slide. And you can, in case we are out of time, you can always send your questions using email. So dynamic behavior of structures. So first of all, as it sounds like its name, it's related to natural properties of the structure. So some of the natural properties of structure we can call like its stiffness, its mass, all of the related properties are affecting the dynamic behavior of a structure. So it can this behavior or like dynamic actions can be caused by any type of loading. It can be induced dynamic analysis, or it can come from like ambient vibration. Normally calculating the behavior of structure or forces, deflections for dynamic behavior or like vibrations, it's kind of complicated, especially if the source is kind of coming from ground motions or like wind-induced vibrations. So most of the time we need good software to find the behavior and design our structures under dynamic load effects. As well as you see here in my slide, I have two like kind of demonstrative pictures and a video actually of what happens if we do not study or like design our structures properly for any kind of dynamic effects. So for example, down here in the right, I have, as you see, a collapsed bridge. It's the photo is coming from a Kobe earthquake in Japan. And as you see, this is due to ground motions. And I have another disastrous like a video here that I can play for you. So this is actually coming from Tacoma Bridge. So the vibrations that you see in this video, it's not coming from ground motions. Actually, it's kind of wind induced. And as you see, like not modeling the structure correctly for dynamic effects. it can cause these kind of failures in the structure. So actually for Tacoma Bridge, it's kind of like that the collapse was related to what they call a flatter effect. The bridge didn't have the complete studies to let the wind flow through it. So all of these vibrations and collapse was happened because of lateral force of winds. But again, you can see that there's also kind of dynamic behavior and vibration in this catastrophic failure. So just to let you know, it's very important, especially for specific regions. You need to also study the dynamic behavior of your structures. What types of dynamic analysis we have? So normally we have so many of them, but the main ones are modal analysis, we have spectral, we have pushover, and we have time history analysis. So these are the main like four types of studies that normally we do for the structures. So in Advanced Design 2020, just to let you know, we have two main new features that we have implemented. So first of all, like for model analysis, in the previous versions, we had just eigen value calculation, but now we have the Ritz method, which is, as you see here, like first of all, it's load oriented. Secondly, it's faster. It ignores residual modes, and also you will get better mass participation using Ritz methods. It's actually very important, and all of it, these benefits are coming from the first one as well, load oriented. So I have a kind of simple graph for you here. So imagine like a beam or like a plank of wood that a person is walking on that. So obviously, like technically, what's going to happen is we have a number of mode shapes or number of modes in a structure based on the number of degrees of freedom that you have in that structure. So technically or theoretically, you can have those so many number of mode shapes. But is all of those mode shapes and modes are useful for you? It's not, because you always have some residual modes, we can call them. So for example, if a person is walking on this beam, as you see, I have my first mode here, which is mode number one. And after that, I have several other residual modes or higher frequency modes. So obviously in this case, this person can just feel the first mode shape, okay? Maybe it's possible that he cannot even feel the second or third or other high residual mode shapes. So in this specific scenario, the first mode shape is governing, and what we are looking for is to capture the modes like this in our structures, the modes that they follow the load orientation. And this is very, very helpful, especially if we are doing like other types of seismic analysis, which they are mode shape based, like spectral analysis and even time history analysis. So the Ritz method will help us so much here, and it will create or generate better and more accurate results with like higher mass participation values. The other improvement that we have in Advanced Design 2020 is we have added time history analysis now. So we have time history analysis in Advanced Design, and I will just show you later on in the software that you can define your ground motion time history coming directly from your accelerograms in the software and apply it directly to your structure. So let's try the features directly in Advanced Design. So now I will open my model in Advanced Design, and I'm going to show you how to use these two specific features for dynamic analysis directly in Advanced Design. Okay, so as you see, I have opened my model in Advanced Design. I have already geometry here. As you see, it's a Greatech logo. It's a structure which is kind of looks like a Greatech logo, and it's a steel structure that I have just created here. To keep everything simple, I have just beam elements, so I have not defined any type of slab or like planar elements. So let's go and see how we can use these two tools on this structure. Okay, so first of all, we will go through our modes. So to create a mode shape or model analysis, we always need to have a kind of dead load or to have it as our mass in the structure. So here I will just create a kind of dead load here to define it as mass of my structure. So there you go, I have it here and it's just self-weight of the structure. Secondly, what I will do is I will define my model analysis from here. So settings, right click, model analysis. So it's here. So we can always go through the properties here on the right column. So let's go and define our modes. So the new feature that I already mentioned, the Ritz vectors, it can be selected from here in the type of method of analysis. So if I click here, I will have my drop down and I will select the Ritz vectors load dependent method. So for my mass matrix, I have several options here. I will just use it as lumped mass, or we can even like go consistent. So we will stay with lumped mass for now here. Then what I'm going to use is here, because I'm using a Ritz method, I will have two options, okay? I can either define the number of modes, so software will just calculate the number of modes that I ask to be calculated, or I can even go with participation ratio, which is even much more better. So as you know, because in some of the codes and the standards, code asks you to have a number of modes until you reach for a specific mass participation ratio. So no, most of the time it is like over 90 or 95% depending on each code. So you can either use participation ratio or you can use number of modes. So for example, here I will continue with number of modes and let's put 5 modes here. And here down here, I'm gonna select my masses. So here I have masses, which is obtained by load combinations. And here you can just select your load combination. As you see, I have just one load case here for now. So I will just assign it to as my masses for model analysis. To keep everything simple, I will just use the self-weight. Click OK. So obviously you can have control on other parameters here, like the damping ratio and eccentricity and others. So I will keep everything simple for now, and I will run my analysis to get my model analysis. So to run the analysis, I can just go here, and do finite element calculations. We click OK, and software will start the analysis. Okay, analysis is done. Now I can go through my results, which in this case is going to be my mode shapes. So to check the mode shapes, you can drop down this list here, go to modes, and here you will have access to all of the modes here. So as you see, I have defined 5 mode shapes to be calculated. So I have these periods here and I can switch between them. So let's say if I want to check the results for first mode shape, I can just click here. It's going to be the displacement and click on this hammer icon and it will show me the results for the first mode shape. So as you see here, this is the first mode shape. I can access the second one just using the same option. This is the second mode shape. And there you go. You have also all of 5 mode shapes that you can access from here. Obviously, you can also animate the mode shapes. So for example, pardon me, here, and animation. And advanced design will create an animation of the mode shape number 2 for this structure. So as you see here, I have the animated displacement of my structure here. This is the second mode shape. So yeah, this is how you can also have the animated results of your mode shapes in advanced design. Okay, so let's stop our animation here and we will go back to model to define also our time history analysis. Okay, let's go back to model. I have my structure here. To define my time history analysis, it's again, you need to define a load case first. So it's going to be here. I right click, create a family, and it's going to be in dynamic temporal loads option. Okay. So here I will add my new type of loads. And there you go here. I have the properties for this, which is named like load case number 2. So here, how you can define your ground acceleration graph or input it in the software is from here. So in solicitation part, you can just drag this menu here, and now we have a new option as accelerogram. And just select it here, and then down here I will have the option to select my accelerogram. Of course, you can input it manually, or also we have some predefined accelerograms here coming from different uh, ground accelerations from uh, some recent or previous earthquakes. So for example, here I can use the El Centro one. Just click here, open, and I will have my time history ground motion accelerogram here. I will have the values from here. And in case you want to change the scale factor, by default the scale is 1. So for example, I can put 10 times here. And here you just let the software know that which direction you want this accelerogram to be applied to the structure. So I will keep it as X horizontal. And I will click OK. And as you see here, it's automatically here. For the results and analysis, you have some options here. So for example, if you want to have your results as distributed in time, I have the option here. Actually, I can go here. So we have a regular range, we have imposed instant, and we have maximum. So in this case, I would like to see my response of the structure at each second or regular range. I will just put here. So I will have it at each 1 second. If you want to change it, you can always change these parameters here. I will go with just default values. So yes, now we have defined as well our time history load case, and let's run the analysis to have our results for time history. Okay, calculation finished. So let's go and first check our displacements. So I will just select my time history load case. And as you see here, I have maximum values, and as well I have a time dependent and step-by-step results for my time series. So for example, if you want to check the status of the structure in 5th second, and just select here, let's go with displacement, and just click here. This is the displacement of my structure in 5th second of my time history record. So same thing for forces. You can check internal forces as well. So for example, if I want to check my axial forces in my members, I can just go here, FX. There you go. And these are my axial forces on this specific second of my ground acceleration. So same thing for other type of results. We will have all of those kind of results for even planar elements. As well, you can have the displacements for I will just here go to member. Okay, I can also calculate the maximum displacements. So if I go here and select maximum and click here, I will have the maximum displacements in the structure. You can always like change the scale here using the Alt Z and displacement scale. So let's put it as, for example, 3 times. There you go. So I have around 2.4 centimeters of displacement right now, maximum. And if you want to also see the animation, time history animation, what's happening to structure, again, I have the tool here. So I just go here, animation, and click on animation. So you will be able to see the behavior of the structure, like the displacements all over your 53 seconds of time history record. So here is the animation. As you see, like I have my time here, which is started from 1 second, and it will continue up to 53 seconds, which is the duration of our seismic excitation. So as you see here, we have the animation started from the first second of my time history curve, and it will continue up to 53 seconds, which is the duration of my seismic accelerogram. So we have kind of high excitation at the beginning seconds, as you see. And then as we see, like at towards the final seconds, it's resting down the structure. Okay, so I will stop my animation here. And now we can go back to my PowerPoint slides to continue the presentation. Okay, great. I'm back into my slides here. So which is yes here. So in case you are interested in the software advanced design, so please feel free like to visit our corporate website www.greatech.com, or you can always contact your local representative for Greatech products. We'll be more than happy to help you on this. We can provide you with a trial licenses and any kind of questions that you have, technical questions you have on the software, we will be more than happy to answer those questions. So one final point, as you may know, we have a special, very interesting event each year for Greatech, which is called Greatech Beam Up Global Digital Conference. So this year it's going to happen like 3rd, 4th, and 5th of June. So it's a worldwide conference. So we will have several classes on all 4 categories of Greatech products like create, simulate, fabricate, and manage. So yeah, please subscribe, or like you can always like register to our classes there. It's going to be very helpful for you, and it's going to be so many information and good knowledge for the users using this global digital conference. Okay, so finally, thank you very much for your time. Now it's the time for your questions. So as I already mentioned, you can either use the question tool for the GoToWebinar to just type in your questions, or feel free to send me an email. I have my email here, farshad.burshak@greatech.com. So thank you very much again, and I'm waiting for your questions. Thanks.